Kilauea goes silent, and that silence is the most dangerous signal of all. 400 meters. That is how high the lava fountains reached 9 days ago when Kilauea erupted for the 42nd time in 14 months. Molten rock launched higher than the Empire State Building. 100,000 tons of sulfur dioxide flooding the Hawaiian sky in a single afternoon. And then, at 11:38 in the evening on February 15th, it stopped. Not slowly, not gradually, stopped. The vents went dark. The instruments went flat. And right now, as you watch this, the ground beneath the most active volcano on the surface of the Earth is doing something that every scientist at the Hawaiian Volcano Observatory is measuring in real time. It is building again. The question is not whether it will erupt. It will. The question is when, and the answer is already inside the data. Kilauea has been erupting since December 23, 2024. Not in a single continuous flow, but in episodes. Discrete, violent explosions of lava fountaining separated by pauses. 42 of them in 14 months, each one following the same sequence. The summit inflates as magma rises from below. Instruments called tiltmeters detect the ground deforming by fractions of a degree. Seismic tremor pulses through the caldera as the pressure builds. And then the crust gives way. Episode 42 lasted 9 hours and 48 minutes. The south vent fountain peaked at 400 meters. The north vent at 300. The eruption column punched to 35,000 feet above sea level. Fine volcanic glass called Pele's hair rained down on communities 20 miles away. The caldera floor deflated 33 microradians as the magma chamber discharged. And then, in the final 2 minutes, the south vent jetted one last time, the north fountain slowly dropped, and both went silent. That was February 15th. Here is what the instruments are showing right now. The tiltmeters at the summit are flat. The Uekahuna tiltmeter, the primary instrument the USGS uses to track inflation and deflation beneath Kilauea's summit, has recorded only 9.2 microradians of inflationary recovery since the end of episode 42. That number matters. During previous pauses in this eruption cycle, the tiltmeter has recorded inflationary rebounds of 20, 26, even 30 microradians before the next episode triggered. The system is not close to that threshold. It is still in the early stages of recharging. The USGS Hawaiian Volcano Observatory published its update on February 19th. The forecast window for episode 43 has shifted to between March 5th and March 20th. A 15-day window. And there is one single variable that will determine whether that window compresses toward its early edge or expands toward its late one. Inflationary tilt. The moment the ground begins to rise again at a sustained and meaningful rate, the model will begin narrowing the forecast. The precision of the prediction scales directly with that one instrument reading, which has not yet moved enough to matter. But here is what most people do not understand about what is happening inside Kilauea right now. The silence is not a pause. It is reloading. Kilauea is a shield volcano. Broad, low, built over hundreds of thousands of years by lava too fluid to form steep slopes. Its profile is nothing like the towering cone most people picture when they imagine a volcano. It rises gently from the ocean floor, spreading wide across the southeastern corner of the big island of Hawaii. Beneath its summit lies a magma reservoir, a connected network of chambers and conduits through which molten basalt moves under pressure. This is not a simple pocket of lava sitting beneath a mountain. It is a plumbing system. Multiple interconnected storage zones at different depths, fed from below by a mantle plume that has been punching through the Pacific Plate in this location for millions of years. Every episode of fountaining is the surface expression of a pressure cycle running through that entire system. Every episode follows the same mechanical sequence. Magma accumulates in the shallow reservoir beneath Halemauma crater. Pressure builds. The tilt instruments detect the inflation in millimeters as the overlying crust is pushed upward. Gas begins to separate from the magma as it rises and the pressure decreases. That gas, primarily water vapor, carbon dioxide, and sulfur dioxide, is what drives the violence of the fountaining. When the pressure exceeds the resistance of the vent system, the conduits open. The lava rises rapidly, the gas expands, and the fountains ignite. What makes the current cycle remarkable is not the individual episodes. It is what they reveal collectively. 42 episodes in 14 months. An eruption every 9 to 12 days with pauses separating each one. The system has established a rhythm, and that rhythm is not weakening. Episode 41, on January 25th, produced the highest fountains of the entire eruption cycle, nearly 1,500 feet. That was a record. Ash and tephra fell 28 miles away in Hilo, a city of 45,000 people. Roads were closed, the park was shut. Pele's hair, those thin filaments of volcanic glass spun by wind from the lava jets, tangled into clumps on the highways and coated car windshields miles from the summit. Episode 42 was slightly smaller, but only because trade winds changed the direction of the debris. The discharge volume, the fountain height, the pressure required to produce both, these were consistent with what the system has been producing for over a year. The magma supply feeding the reservoir has not diminished, which means the 43rd episode will not be smaller. If you are following this eruption closely and want to understand what the instruments are telling us before the next fountaining begins, subscribe now. Every update in this eruption cycle is covered here as the data comes in, and episode 43 is being tracked in real time. A like also helps this reach people who want to understand what is actually happening beneath the Pacific, not just the headlines. And if you have a question about the science, drop it in the comments. The most specific questions get answered directly in the follow-up video. Back to the data. The tiltmeter knows exactly when episode 43 is coming. Most people assume that predicting a volcanic eruption is guesswork. It is not. Not here, not at this volcano. The USGS Hawaiian Volcano Observatory operates a monitoring network that covers Kilauea with a density that rivals any volcano observation system on Earth. Tiltmeters at the summit record ground deformation to sub-microradian precision. Seismometers detect tremor accompanying magma movement. Gas sensors measure sulfur dioxide emissions continuously, providing a direct window into the degassing behavior of the magma beneath the surface. A laser rangefinder measures the elevation of the crater floor in real time. Webcams positioned at multiple points around the crater rim stream live video to servers and to the public 24 hours a day. Everything feeds into a tilt recharge model calibrated against 42 prior episodes in this same eruption cycle. Each one provides another data point. Each one refines the timing of the next. The model works by tracking the rate at which inflationary tilt accumulates after each episode ends. The faster the tilt accumulates, the more rapidly the magma chamber is refilling, and the sooner the next fountaining window arrives. When the tilt climbs steeply, the window compresses to days. When it climbs slowly, as it is doing right now, the window stretches to weeks. The model is not speculation. It is pattern recognition running on one of the most exhaustively documented episodic eruptions in the history of volcanology. This type of episodic behavior, a cycle of rapid inflation followed by violent fountaining, followed by deflation and then recharge, was last observed at Kilauea between 1983 and 1986 at the start of the Pu'u'o eruption. That eruption eventually transitioned from episodic fountaining to continuous effusion and ran for 35 years, reshaping entire sections of the Big Island's coastline and destroying hundreds of homes. Scientists watching the current cycle are not predicting a repeat of that sequence, but the parallel is not lost on them. The system that produced 35 years of near-continuous eruption began with the same kind of episodic rhythm that is playing out in Halemauma crater today. And right now, the pattern is clear. The system is between episodes. The reservoir is refilling. The forecast window is open. And when inflationary tilt begins to register on the instruments at a rate that matches what preceded episodes 41 and 42, The window will compress from 15 days to days, and then from days to hours. The clock is not running on assumptions. It is running on physics. When episode 43 begins, it will follow a sequence the instruments have now captured 42 times. Precursory activity comes first. This is the fingerprint of magma approaching the surface. Small overflows from one or both vents. Lava appearing at the top of the vent and spilling onto the crater floor in pulses. A phenomenon called gas pistoning, where cycles of rising and draining lava in the vent create rhythmic bursts of incandescence visible on the webcams even before fountaining begins. A sharp increase in seismic tremor. A rapid shift in tilt at the Uekahuna tiltmeter from inflation to deflation, the moment the chamber begins discharging. Then, within minutes of that tilt switch, the fontaines ignite. The south vent first, then the north, both reaching hundreds of meters within the opening hour. The eruption column rising toward 30,000 feet or higher, a plume of gas and ash spreading downwind. And somewhere between 8 hours and 8 days later, the system discharges, deflates, and the silence returns. The lava flows will remain confined within the caldera of Hawaii Volcanoes National Park. The rift zones on the east and southwest flanks of the volcano, the areas that produced the catastrophic 2018 eruption that destroyed 700 homes and added nearly 1 square mile of new land to the Big Island, show no significant activity. The current eruption is a summit event. It is happening in a closed area of the park, far from populated communities. The 43rd episode will be spectacular. It will be measurable. It will be predicted in advance, at least to within a window of days, by instruments that are already recording the data that makes the prediction possible. But what this eruption represents extends beyond a single event on a single island in the Pacific. The forecasting model running at Kilauea right now is the same class of model that volcanologists want to apply to every dangerous volcano on Earth. Vesuvius, which sits above 3 million people in the Naples metropolitan area and last erupted in 1944. Rainier, the most glaciated peak in the contiguous United States, whose flanks hold enough ice to generate catastrophic mud flows, reaching the suburbs of Seattle and Tacoma if an eruption occurs. Popocatépetl, which looms over the eastern edge of Mexico City and has been in a state of elevated unrest for decades. These are volcanoes that have not erupted on a predictable episodic schedule in living memory. The tools being tested and refined at Kilauea, a volcano that erupts on a schedule measured in days and weeks rather than decades and centuries, are a proof of concept. Every episode the model calls correctly is evidence that prediction is not only possible but scalable. Every episode that surprises the model is a data point that makes the next forecast more accurate. The 43rd episode is coming. The instruments are watching. The tiltmeter is waiting for the one reading that will compress a 15-day window into something precise enough to matter. Right now, the vents above Halemauma crater are quiet. The plumes rising from them are gas, not lava. The crater floor, covered in fresh basalt from 42 prior episodes, is cooling slowly in the Hawaiian air. Webcam images show no incandescence, no glow, no sign of the violence that 9 days ago launched rock into the stratosphere. But below the surface, at depths that no camera can reach and no eye can see, magma is moving upward through conduits that have been opening and closing for over 14 months. The tiltmeter is ticking. The sulfur dioxide sensors are reading. The seismometers are listening for the first tremor pulse that signals the system is approaching its threshold. The silence will not last. It never does. Episode 43 is coming. The instruments already know it. The only question is when the tiltmeter finally moves and the forecast window compresses to its final hours. The science built over 14 months of continuous monitoring will have been precise enough to call exactly what happens next.